Today we shall prove the existence of general economic equilibrium by means of a fixed point theorem. More precisely, the Brouwer fixed point theorem. In order to obtain this result, we shall make some simplifying assumptions. The first, that large lambda is equal to the non-negative ortant but the null price system, of course. This means that for every non-null price system, every firm succeeds in maximizing its profit, and every consumer has a definite budget constraint. Clearly, this assumption is not generally true, as you surely remember from the second part of this course. However, this is not a big problem. It can be resolved easily, as we shall see afterwards, by a suitable assumption. Moreover, we shall suppose that for every price system in this set, also Riemann functions are non-empty values. In other terms, every consumer is able to maximize its preferences or utility. Also, this assumption is clearly unrealistic. Do you remember? If some price is equal to zero, a maximal element may not exist. However, for the sake of simplicity, let us assume all these starting points of our reasoning. Moreover, we shall suppose that choices of every subject are univocally determined. In other terms, for every firm there is only one maximizing process, and for every consumer there is only one maximized value. This is not generally true, but afterwards we shall see a more general theorem which permits the existence of multiple choices. However, from all these assumptions, it follows that there is an excess demand function and not correspondence. Excess demand function, which we shall denote by small z, which is defined in delta. Do you remember, it's not necessary to consider all price systems, but only the normalized ones, and takes values in the n-dimensional Euclidean space. This function associated with every price system in delta, the unique vector of excess of demands of the economy. Is it clear? We shall suppose, however, that Z is continuous, in order clearly to apply Brouwer's theorem. Well, these are our assumptions. Moreover, strict Varda's law holds. For every price system in delta, the inner product between P and Z of P is equal to 0. In other terms, P and Z of P are orthogonal. Given all these assumptions, it is possible to prove the existence of a P star in delta such that Z of P star is less or equal to 0. Implicitly we admit free disposal, and therefore equilibrium can be defined in this weakened form. Do you remember? Well, in order to prove the existence of equilibrium by a theorem due to arrow and arm, we must introduce a supplementary function. The function Z plus defined in delta, which takes values in the non-negative order. This is a substantial function of a real, the actual excess of demand. In other terms, the non-negative excess of demand. Since our since our goal is to show that there is a price system according to which no positive excess of demand exists, the relevant concept here is Z plus, which is defined in this way. Z plus I of P is nothing but max between Z I of P and 0. This is the definition of this function. So, for every P in delta, for every I, which ranges from 1 to n. In other terms, take any price system P. You have an excess of demand, 1 for each good. Some of these are negative numbers, of course, but in this case, this function substitutes to this negative number 0. It cancels the negative excess of demand and substitutes it with 0. For all the positive excess of demand, Z plus I of P is exactly equal to Z I of P. This is a real, the actual excess of demand. In other terms, the positive or non-negative excess of demand. Well, in order to prove the existence of equilibrium, at this point it is sufficient to show that Z there exists a P star in delta such that Z plus of P star is equal to 0. It is clear that if this equality holds, there are no positive excess of demand. Probably there are negative excess of demand, but these are admitted. The important thing is to exclude the existence of positive excess of demand. Is it clear? So, in order to prove the existence of P star which verifies this inequality, you must prove the existence of P star which verifies this equality. How to prove the theorem? By a modified form of a traditional Varrogian tâtonnement. You remember the adjustment rule to which I made a reference in the introductory part. According to the tâtonnement, if there is on a market a positive excess of demand, price increases. If there is a negative excess of demand, price decreases. In this case, if you consider the function Z plus, only positive excess of demand are possible. And you follow the following rule. If for a good Z plus I of P is a positive number, in other terms there is a positive excess of demand, increase the price of that good, say, of the same amount of excess of demand. For example, excess of demand of good I is equal to 10 units, you increase the price of good I by 10 units. Simply this. Is a modified form of tâtonnement. Tâtonnement. Because for the goods for which there is a negative excess of demand, prices remain unchanged. It does represent this adjustment process by means of a graphic. Put on the axis the prices. Here, in this case, there are only two goods. This is delta, large delta, our unit simplex. Take any price system like this, for example. P. This is this vector. Now consider the excess of demand Z of P. By Varna's law, Z of P is orthogonal to P. So, for example, Z of P is this vector. Note that this angle is 90 degrees, so there is orthogonality between these two vectors. Now let us pass to vector Z plus. Vector Z plus is obtained from Z by cancelling every negative excess of demand and substituting them with zeros. In this case, you have a positive excess of demand of good 1 and a negative excess of demand of good 2. So Z plus is this vector. What is the difference between Z of P and Z plus of P? See, the second coordinate of Z of P is nullified when you pass to Z plus of P, because it is a negative number, while the first component, which is positive, remains unchanged. So, Varnagian tâtonnement, the modified form of Varnagian tâtonnement is the following. Add to the price of good 1 the entire excess of demand. So we obtain another price system like these, whose components are, for the first good, P1 plus Z1 of P. For the second component, P2. Since for the second good there is a negative excess of demand, the price of good 2 remains unchanged. We pass from P to P prime. The problem is clearly that P prime is not an element of delta. The sum of the components of P prime, generally speaking, if some excess of demand is a positive number, will be greater than 1, the sum of components of P. No problem. You can normalize vector P prime by reducing proportion every component with P prime in order to obtain this point, which is on inverse at depth. This point, which will be denoted by f of P, is proportional to P prime, and therefore, since there is no monetary illusion, both for firms and consumers, all excess of demand in P prime will be equal to the excess of demand in f of P. Is it clear? By these two operations, alter vector p according to the positive excess of demand, normalize p in order to return in delta, you obtain a function f defined in delta which takes values in delta. And you observe that in this way you obtain a function which obeys to the one of assumptions of Brouwer fixed point theory. A function defined in a non-empty convex and compact set which takes values in the same set. Clearly, since z, the excess of demand function, is continuous, also z plus will be continuous. It is easy to show this, and also f will be continuous. To be precise, f is defined in the following way. F of p is defined as p plus z plus of p on sum for I which ranges from 1 to n of pi times z plus I of p. This is the exact definition of function f. I repeat, to the original price system P, add the vector of the actual excess of demand, non-negative excess of demand. You obtain P prime. Then divide this vector by this scalar, which is nothing but the sum of the components of this vector. Clearly, the sum of the components of f of p is equal to 1. This is simple normalization. And this function is clearly continuous, since z plus is continuous, and this is a continuous transformation. Moreover, this function is well defined because in the denominator you have sum of pi, which is 1, plus non-negative numbers. So the denominator is greater or equal to 1. The function is well defined. Is it clear? This is the modified form of Barrage-Taton, and after a short interval, we shall prove that every fixed point of this function is in reality an equilibrium for our economy. The fixed point theorem implies the existence of equilibrium.